All right, 2.7. We're going to solve some equations now involving rational functions. Solve equations. It's not working. I don't know why it's not working. Okay, you did this in Algebra 2. It was Chapter 9, which tends to be a lower of the chapters. It's hard. Okay, this is what you want to do. There's really just two things to remember. Number one, you're going to try and clear your fractions. Clear fractions. Like, I don't know what's going on. Is it the screen or my pen? Look how bad that looks. Looks like a 3-year-old wrote that. Clear fractions. Wow. It's terrible. The other thing that you're going to do is you also need to check for extraneous solutions. Check for extraneous solutions. Bless you. And you know that has happened before with us, where we had to check for extraneous solutions. And it happens whenever the functions that we're dealing with are not, their domain is not all real numbers. Like we had to check inside of a radical to make sure that the x was okay. So if you plug that in, you get a negative number in there, it's going to be bad. So clear fractions, check for extraneous solutions. So we're going to do, I have 6 problems. I only got through 5 in my other class. So let's see if we can get through all 6. Or I have 5 to do. Okay, here we go. We're going to solve x plus 3 over x is equal to 4. Mr. Parsons is in the library, right? I'm going to go get some iPad help from him, I think. This is terrible. All right. So here we go. We're going to solve this. All right, if you look at it, we only have one variable. It's just x. But x is in a fraction, and it's very confusing. So what we're going to do is we're going to multiply both sides of this equation by the LCD, which happens to be x. Do you remember this?
Yeah.
Okay. So we're going to go x times x is x squared. We're going to go x times 3 over x. EDK, you're back. Shout out. All right, plus.
You shout out.
This is 3x over x. And what happens is your x's reduce, leaving you with just 3. Right? Do you see that? Do I need to show that step? I don't need to show that. You guys are in ham. Equals 4 times x is 4x. Okay, now we have a quadratic to solve. So when you have a quadratic to solve, you want to bring everything over to one side. So I have x squared minus 4x plus 3 equals 0. My preferred method of solving a quadratic would be to factor it. You can, any of the other methods. Matthew, complete the square. Sometimes you'll have to do quadratic formula. X minus 3, x minus 1. All right, we'll see you, Nick. So x is equal to 3 and positive 1. And those are our answers. And check to see if they're extraneous, and they're not, because the only thing that would have been extraneous would have been 0. If you plug it in right here, it doesn't work, because you get 3 over 0. But 3 and 1 are perfect. Okay? You did this kind of stuff last year. Let's try another one. Number 2. Okay. Let's do 2x over x minus 1. Was that the 7-minute bell? Please tell me no. 1:15. Yep. All right, 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Okay. Excuse me. I want to clear out my fractions. But I need to know what the LCD is, okay? And LCD are going to be, what are the multiples that go into this and that I can go ahead and, reduce things. So I'm going to factor this one right here. So everything else stays the same. I know it's a pain in the butt to rewrite this. 1 over x minus 3. And then this one factors, we just factored that. And that's going to be x minus 3 and x minus 1. Ooh, look at that. I know, right? They do that all the time, don't they? Who comes up with these problems? People who have time. Okay. Here we go. We're going to multiply everybody through by x minus 1 times x minus 3. Do you remember doing this kind of thing last year? Yeah, good. Okay. The thing that people get confused, they think they're going to multiply the bottom. You're not multiplying any of the denominators because this is really like over 1. And you're multiplying top times top and bottom times bottom of everything. Okay? So we're going here. And what happens is our x minus 1s are going to reduce. And we're left with 2x times x minus 3. Okay? Here we multiply, and our x minus 3's reduce, leaving us with 1 times x minus 1. And then over here, they both reduce. We have an x minus 3 on top and bottom, and x minus 1 on top and bottom, and we're left with 2. Okay, now we've cleared all our fractions and we've created a quadratic to solve.
Wait, why didn't you multiply the single x by 1?
This one?
Yeah, why didn't you multiply that by x?
I multiplied it by x minus 1.
Oh, okay.
Because the x minus 3 is reduced?
Yeah, I see.
Okay, cool. All right, we get 2x squared minus 6x plus x minus 1 equals 2. 2x squared. I have a negative 6x and a positive x make negative 5x. And then I bring the negative, I subtract 2 over and get minus 3. And now I need to factor this. And I know there are some diehards out there that are not going to do the star method, Ricky, and that's okay. We're all right with that. I would probably do star method on this, but you don't really even need to. Let me show you the way that I learned how to factor when I was your age. Yes, 100 years ago. We did 2x times x, because 2x squared, that's the only option, right? 2x times x. Now, negative 3 only has 2 options. Well, it's got a couple of options. It could either be 3 and 1 or 1 and 3, and one of them's negative. So if I put a negative 3 here, I get negative 6, and positive 1 there would make negative 5 in the middle. That's the way I learned how to factor. It was like guess and check.
That's hard.
It is. You had to guess, you had to check. Yeah, there were lots of I cried a lot. Okay. Here we go. And then I'd ask my dad, and then he'd make me feel really dumb. Okay. So we get, sorry, Dad, love you. X equals negative 1/2.
Is he watching?
No. Positive 3. But you never know. He's watching from heaven. No, I'm just kidding. He's alive.
Yeah, you better hope he never sees this.
Okay, so now, I was like, that was dark. Now go ahead and plug them back in to make sure they're okay. And 3 is not okay. See that? See, in the very original, you have to go to what you started with, the original problem. 3 goes in, and it's extraneous, because I get 1 over 0. So I need to cross off 3 and just say x equals negative 1/2 is my answer. It's not that you did anything wrong there. It's just it comes up extraneous. All right, number 3. We're going. We're going to do a chemistry problem. Are there any chemists out there?
Stop it.
Your chemistry teachers, yes, they're smarter than your math teachers because they have to know the math and know the chemistry. I just have to know the math. Okay. It says right here, how much pure acid, we're going to do a mixture problem. How much pure acid are you going to add to a 50 milliliter of 35% acid solution to get a 75% acid mixture? Can you imagine this? Or is it like totally not making sense? No, you don't want to waste your acid. Yeah. Like to here? All right, so you have 50 milliliters and 35% of it is acid in there, okay? we're going to add pure acid to it. We want to know how many milliliters so that our mixture is now 75%. Really? So this is a bad problem anyways?
Yeah, like you're not supposed to have acid.
Well, we're going dangerous on this one. Okay. Now, let me tell you. The milliliters of pure acid over the milliliters of mixture is going to equal the percent of acid. Does that make sense? It's kind of like if you took a quiz and I took the number right that you had over the total numbers, you would get your percentage on the quiz, right? Okay. So let's first find out how many milliliters are already in this of pure acid. So I know that there are 35% times 50. And that gives me 17.5 milliliters. There's already 17.5 milliliters. It's kind of like when you do this, like what grade do I need to get on this test in order to keep my A in the class? Like that, that's what it is. So we're going to take X amount of pure acid. We're going to add it to the 17.5. And that is going to be divided by the X that we're adding plus the 50 that we already have. That's going to give me 75%. Exactly. Someone else had a different way to do it, and it was great. In my other class, I loved it. This is the way the book teaches it. Okay? There's other ways to do this. But this makes sense to me. Dang. Here's the amount of pure acid. That's the amount of total acid, and then I have to cross multiply and solve. I will finish this and one more problem. So once you get it set up like this, you can go ahead and cross multiply. You get 0.75x plus, don't forget to distribute to the 50, which gives us 37.5 equals x plus 17.5. Subtract the 0.75x over to the other side. 0.75x. So then you get 37.5 equals 0.25x. That's a 7. Sorry, I don't know what's going on. Plus 17.5. Okay, go ahead and subtract 17.5 to the other side. And then you get, let's see, to divide by 0.25, divided by 0.25, x equals 80. 80 what? 80 milliliters of pure acid that you need to add to the 50 to get the 75%. Okay, the last one. What number is this? Sorry, number 4. All right, if you tuned in now, because I want viewers so much, take my time in class. No, I was trying to get through as fast as I could. I really was. It was just assembly. We're out, 5 minutes early, blah, blah, blah. Okay, number 4. It says we are going to find, 7th period just started. Find the dimensions of a rectangle. Someone's trying to bother me. Of a rectangle given that the area is 200 feet. We're in America. It's feet. We need to find, well, there's a whole bunch of rectangles that give us an area of 200 feet. There's an infinite amount of them. But we want to find the one that gives us the smallest perimeter. The one with the smallest perimeter. So, this is a little different than the question that we did last time was given the perimeter. Here's the fence. Now come up with the chicken coop. This one is, here's the area. And you got to minimize the perimeter. Okay, let's go ahead and here's our rectangle. Here's x and here's y. And we know that x times y is going to equal 200. And then the perimeter of this thing is 2x plus 2y. And we want to find the smallest perimeter. Okay, so let's take this right here and let's solve for y. Y equals 200 divided by x. And then take that and plug it into this equation. So I'll get the perimeter is 2x plus 2 times 200 over x. That's equal to the perimeter. So perimeter is 2x plus 400 over x. You're going to get this problem in calculus, and it's very exciting because you take the derivative, you set it equal to 0, and you find the minimum. But in our case, we're going to graph this on our calculator. Go to your calculator and graph under y1. We're going to graph this, and we're going to find the minimum of it. It's going to have a minimum. It's not a parabola. It's a rational function, and it has a minimum, and we're going to find that minimum. So I went to my calculator, and I graphed this, and I had to change the window a bit. I ended up doing x was from 0 to 100. So let's see. I knew that I only needed the positive x's and the positive y's for this. So I did 0 to 100 for both. 0 to 100. And I got this graph. It's a rational function with a slant asymptote. There's actually another part of it down here, but we don't care. And then our minimum is right here. And I did second trace, calculate the minimum. And I got that x was 14.14. Okay, and then to find out, we want the dimensions, so we're going to go back and plug that in. Y is equal to 200 divided by 14.14. What do you know? It's a square again. 14.14 is also y feet. So that would give us the smallest perimeter. Okay, looks like that's it. All right, good luck.